Every second, your body wages an invisible war against a vast, relentless enemy. Bacteria, viruses, parasites, and other invaders attack from every direction, searching for a way inside. And when one of them finds a tiny wound or a hidden weakness, it triggers a full-scale defense. Your immune system is a massive army with cells as its soldiers, weapons, and armor. And when an invader breaches your defenses, it unleashes a wave of microscopic carnage, all to protect you from harm. This is our channel. And today we're answering a viewer question. What would happen if someone was stabbed in the heart? It's important to know what happens to the body after a stab wound to the heart, because it can be life-threatening. If you stab someone in the heart, they will die. To see why, let's follow the journey of one of these dangerous invaders. Say a virus, as it attacks the human body and faces off against a microscopic army that defends it. A single misplaced step could breach your body's first line of defense. A cut, a scrape, even a tiny insect bite could let invaders like bacteria and viruses slip through and into your bloodstream. Now the battle begins as the enemy moves through your body, setting up shop in vulnerable cells. Your immune system sounds the alarm, triggering a cascade of chemical signals that alert nearby soldiers to the danger ahead. First responders like macrophages and neutrophils rush to the front lines. These phagocytes engulf and destroy invaders by eating them whole. Macrophages are quick to arrive on the scene, identifying threats using pattern recognition receptors that spot telltale molecular shapes on the surface of invaders. Their arsenal includes chemical weapons like hydrogen peroxide and nitric oxide that break down invader cell walls. Neutrophils, meanwhile, are the heavy lifters, using enzymes to digest their victims. They also release webs of DNA to track nearby enemies. But while these foot soldiers do a great job containing the threat, they aren't equipped to identify the enemy. That's where dendritic cells come in. These cells act as scouts, traveling to the lymph nodes to identify the enemy and sound a general alarm. There, they present pieces of the threat to waiting T cells, triggering an orchestrated response from the rest of the immune system with new orders in hand. T cells leave the lymph nodes and head toward the injury site, releasing chemical signals that help recruit more macrophages and neutrophils to the fight. But they also have another mission: activating B cells. These cells act like weapon factories, churning out antibodies that tag the enemy for destruction. Each antibody is perfectly suited to disarm a particular threat, binding two unique features on its surface. And once an antibody finds its target, it marks the invader for destruction by other immune cells. Some antibodies neutralize threats directly, blocking viruses from entering healthy cells or breaking down bacterial flagella so they can no longer move around in your body. Others bind to pathogens, making them sticky so they clump together and can infect more cells. Then there are antibodies that bind to the toxins that some pathogens produce, stopping them from harming healthy tissue. The infected site becomes a war zone as the battle rages and casualties mount on both sides. Some pathogens manage to infect healthy cells, replicating and spreading throughout the body. Meanwhile, other invaders get caught up in the sticky webs of fibrinogen, a protein that forms blood clots around wounds. But most of the enemy is taken out by immune cells, macrophages, breaking them down and turning their parts into building blocks to repair damaged tissue. Other immune cells release chemical signals that promote healing, triggering nearby cells to start repairing damaged tissue. But not everything goes according to plan. Sometimes pathogens manage to set up shop in immune cells themselves, hiding from antibodies and other weapons until the battle is over. Others release toxins that weaken the body's defenses. Still, others trigger an overwhelming inflammatory response that damages healthy tissue. Even the weapons used to defend the body can sometimes cause harm. For example, the chemicals released by immune cells to promote healing can also cause widespread clotting throughout the body, cutting off oxygen to vital organs. That's what happened to George Meningo, a soldier who died in 2004 after being wounded in Iraq. After he was hit, his immune system went into overdrive, releasing too many clotting proteins into his bloodstream, which blocked blood flow to his heart. Despite these setbacks, most of the time the immune system wins the war. And when it does, it leaves behind special memory cells ready to strike faster the next time the same threat shows up. That's how vaccines work. By introducing a harmless version of a pathogen to the body, they trigger an immune response that creates memory cells without causing disease. So if the real thing ever shows up, the body is ready to fight back quickly. Let's go back to what would happen if someone was stabbed in the heart. The heart pumps blood throughout the body, carrying oxygen and nutrients to the cells and organs that need them to survive. If a knife pierces the heart, it can damage the heart muscle itself, preventing it from pumping blood effectively. This can lead to a rapid drop in blood pressure and a potentially fatal loss of blood. Immune cells can't reach the virus hiding in the heart, at least not without some help. So instead, they focus their efforts on the blood and lymph vessels near the wound, blocking blood loss and trying to neutralize the threat. But with every heartbeat, more blood gets pumped into the wound, carrying new invaders into the heart and throughout the body. Soon, the entire cardiovascular system becomes a battleground as immune cells fight to contain the damage and prevent the virus from spreading. If the immune system is slow to respond, the virus can overwhelm the body, infecting more cells and damaging more tissue before antibodies arrive. That means more blood loss, more toxins, and a growing number of weak spots throughout the body. Eventually, the virus may even make its way to the brain, causing seizures or strokes. The heart, meanwhile, continues to pump, trying to push blood through damaged vessels and around clogged arteries. But as the battle rages on, the strain weakens the heart muscle, making it harder and harder to circulate blood. If the immune system can't stop the bleeding and neutralize the virus quickly, the heart may eventually fail. Without the ability to pump blood and deliver oxygen to the body's other cells, the result is inevitable. But the immune system is remarkably efficient, especially when it has reinforcements on the way. In real life, when someone is stabbed, medical professionals rush to the scene to help. Doctors can use a tourniquet to stop blood flow to a limb, minimizing blood loss and giving the immune system a chance to contain the threat. They can also administer antibiotics to neutralize the enemy, giving the immune system a hand in the fight. And in some cases, they can even replace the heart altogether, giving the immune system time to finish the job. Amazingly, even if the heart is beyond repair, the body can sometimes recover from the shock of cardiac arrest. If medical professionals arrive in time, they can restore normal heart rhythm and restart the organ manually. In those cases, the immune system can clean up the mess left behind by the virus, and the body can begin to heal. But if the heart stops beating for too long, the result is irreversible. Brain cells die after just a few minutes without oxygen, and the longer the heart remains inactive, the more damage is done to other vital organs. That's why it's so important to act fast when someone suffers cardiac arrest. Every second counts in the fight to save their life. When a virus enters the body, it triggers a microscopic war that takes place mostly out of sight. The immune system, a complex network of cells and weapons, works tirelessly to protect us from harm. Although sometimes this war can escalate into a full-blown battle, causing symptoms like fever, inflammation, and fatigue. But most of the time, our immune system wins the war, leaving behind special memory cells that help it fight future battles more efficiently. So next time you feel a tickle in your throat or a bug bite on your arm, remember that a microscopic battle is raging inside you, and your immune system is there to defend you.